In today's video, I will be guiding you through a step-by-step tutorial on how to configure and bring your elevator model to life with Modulux V2. So, what is Modulux V2? It is a new elevator controller that is focused on efficiency, modularity, and accuracy. Now, let's start with the key features. Some of you guys may remember this game, and if you don't, this is my childhood elevator showcase place, which all of the elevators run on Modulux V2. Now, the characteristics that make up these elevators don't actually run natively on the controller. These are mostly ran by third-party plugin modules. Now, I know you'll be asking, what are third-party plugin modules? Simply put, they're external scripts you can write to interact with the internal controller stuff. Now, these plugin modules here will be provided by default. Now, how exactly do I go about writing a plugin module? Well, the process is actually not that difficult. So what you want to do is head over into your plugins folder inside the controller and click on the little plus icon here, and you're going to see this menu pop up. You're going to want to look for module script. If it does not show up, you can type it in and open it here. Now what you'll see is a new module script. You can name this whatever you like. It does not matter what it's called. So in this case, I'm just going to name it test. And so now you'll see that we have this code here. And what we're going to want to do is paste in this code right here and hit enter, and that will create the end. So what this means is that this tells the elevator controller itself to recognize this plugin module as an actual plugin module. So this will be invoked and this will be passed in. So what this controller variable does, this is the whole controller system for the elevator. So you can do whatever you want with this. But in our case, we're just going to type print hello, just so we know that this works. And once we run the game, we're just going to open the output first so we can see it come through. Now you'll see I have a lot of stuff going on in the output here, but if we scroll up and take a look, you'll see that our little hello print has come up. It says hello server test line 5. And if we click on it, it takes us to where the code was executed. If you would like to make more advanced plugin modules, I will make another tutorial for that in the future. I know the previous section was a bit lengthy. This section is about movement. You may notice how silky smooth the elevator's animations are, specifically the car movement. Here's a comparison between standard server-sided movement and Modulux V2's movement. As you can see, the environment on the left-hand side is pretty heavy and is causing the elevator to end up pretty choppy. How is Modulux V2 so modular? With the use of the plugin modules, it allows for a lot of connectivity between the internal controller and a third-party script. With this in mind, you can create many cool things with this. It also follows the naming convention almost exactly the same as Cortex elevators. This means that migrating from Cortex is a pretty simple process. Modulux V2 focuses heavily on the accuracy of its behavior to simulate real-life elevators. While the movement and door animation plays a big role in this, there are more things that tap into it, such as taking into account leveling, lantern behavior, and more. So, now that I've given you a brief overview of Modulux V2, let's begin configuring it. So here's a base model that we're going to be using for this tutorial. So here we have an IVX 6th generation elevator. Now this model will become the base model, so when this releases, you guys will be able to use this as well. So let's give a quick overview over the settings. So what we're going to want to do is we're going to go into controller, and inside the controller you'll see the config module. So go ahead and open that, and you'll be greeted with a lot of code here. Now don't fret, this is a lot of code, but I will be going over every single step on how to configure the elevator properly. Alright, so let's go ahead and start with our speeds. Here we are given 3 speeds: open, close, and nudge speed. Now opening and closing speed are pretty straightforward. That just means time in seconds for how long the doors will open for. Nudge speed is basically if the doors are nudging, then you can assign a separate value or duration for when the doors are nudging. Now, moving on to open and open sound delay. Open delay is the delay in seconds before the door begins to open, and the sound delay is the same thing, but it is not coinciding with this delay, so these are two separate delays. So if you set this to 1 second and leave this as 0.2, this sound delay will play after 0.2 seconds, while the door will start to open after 1 second. And these behave the same, just in closing. Now let's move on to the door timers. This one may look a little bit daunting at first, but do not fear, this is actually very straightforward. So open no call just means that if you press the door open button inside the elevator, that is what will be used here. Open on stop just means that if the elevator has traveled to a floor and is opening, there are no hall calls, then it will use this timer. This timer means that if the call button has been pressed, that means that this timer will be used. So you can set this to like 8 seconds, for example. Nudge timer is pretty straightforward. That's just how long the doors will be able to stay open for before it goes into nudge mode. Now, direction switch delay seems a little bit confusing at first, but if you read the comment, this just means delay in seconds before the doors will reopen and answer the opposite call. So, if the elevator has received both an up and down call on the same floor, it will answer one call first, then after the doors close, wait this many seconds, and then answer the next call. Now for the acceleration stages, this part gets a lot of people, but again, I will teach you on how exactly to set this up. So this looks a little daunting at first, so we're going to go and delete some stuff here, just starting with the basics. Now, if we take a look at this here, we have opening and acceleration stages. So all of this whole section that I have highlighted here is for opening, and then this is for closing. So when you look at opening, and if you look at acceleration stages, this just is where you can configure the doors to accelerate. So rate is basically a value by how much the speed will change. So for example, the speed will increment by this number every frame. This is the maximum speed that the doors will reach in this entry. So math.huge just means that it is going to be capped at the maximum door speed, which is being followed by this value. So if you set it to a super high value, it does not matter. It will always be constrained to this speed right here. And same with closing and whatnot. And for delay, let's say you have a separate entry. So let's go and add an entry at the bottom here. So if we have another entry, then this delay will basically tell the doors, hey, this section is done, this speed has been reached. And then let's say you set this to 1 second. Think about it this way. This is done, and after 1 second, it will iterate to the next one. So that's how this works. Pretty straightforward. Moving on to the slowdown section, this is actually a little bit confusing at first, but once I explain everything, it should make more sense. So here is a slowdown distance. This value controls when the doors should start to slow down when they reach their open or close position. So now, if you read this comment here, distance threshold from 0 to 1. So that is why you're seeing this weird number right here. So let's just set it to a more specific 0.5 value. This means that the doors will start to slow down about halfway before reaching its goal position. So if we take a look here, you'll see that when I open the door, it starts to slow down right around that halfway point. And now we have our final slowdown point. This is the offset, using the same threshold's distance, that the doors will be from their open or closed position when the minimum speed is reached. In other words, when the door has reached this speed right here, then they will be this many studs away from the open position. And this is the final speed, so the speed the doors will slow down to. Do not set this to 0 if you don't want your doors getting stuck. Keep it at this value, because that just means that if the doors fail to reach their position fully, then they will have this much speed to be able to correct themselves. Now moving on to this little section here, this one isn't very well detailed. I will add comments to it after this, do not worry, but I'll explain it anyway. It's named in a funky way, but essentially what this means is when you look at real-life elevators, you'll see how on most doors, the way the outer doors kind of shake and bounce, that is what this is for. So you can either enable it or disable it altogether, and you can also customize how intense it is. That's pretty much how it works. And then the door clutch offset determines the offset for the doors. So if the outer doors have a little bit of an offset, just like real-life elevators, then this is where you'll configure it. Tolerance, offset, and studs, the outer doors will be able to clutch with the inner doors. Now, keeping all of this in mind, this is pretty much all the same in the closing section. Alrighty, so here we are at the movement configuration for the elevator. Now, the movement configuration is pretty straightforward, but I'm just going to go ahead and briefly go through all of them. So first, you will see that they're actually separated by up and down travel. So basically, up travel, you just follow all the values. So start delay is just how many seconds the elevator will take to start moving. And then the motor start delay is how many seconds before the motor sound will start playing. So these two are two different delays. So for example, this would not start and then this after. They both start at the same time. So you gotta kind of time these at the right time. Then traveling speed, I just have this set to a decimal because I converted it from actual measurements, but you can set this to whatever you like. It doesn't really matter. Moving on to acceleration, we have the rate, which if you look at this comment here, you'll see that I'm using some sort of weird math equation that you guys might not understand, but I kind of explained it. So this is the travel speed divided by the seconds it would take for the elevator to reach top speed in degrees. Now, that just basically gives me the rate of acceleration. You do not have to use this, but I do recommend it. It is easier because instead of changing all of this, only change what's in this here. So for example, if you want to make the elevator take 4 seconds to reach top speed, you just enter 4 seconds here. Gradual deceleration time is just a gradual acceleration, so the elevator doesn't immediately take off. It just kind of like starts smoothly and then gradually gets to its peak rate. So that's what this is for. Moving on to stopping, you've got distance to stop. Now this may seem a little bit daunting at first because 0.2 seems like a very short distance to stop, but this is actually factored in by the speed. So the higher the elevator, the more this distance will increase no matter what you set this to. The increment type is actually currently unused, but will have a use later, so leave this as is. Slow down final offset is where the elevator will be from the floor by the time this final speed has been reached. So when the elevator slows down and it hits this speed right here, this offset is what is determined where the elevator should be. So if I set this to 1, then the elevator will be positioned 1 stud above the floor when this speed is reached. If you make it -1, then the elevator car will be 1 stud below the floor when this speed is reached. These two values here are used for hydraulic leveling. So if you want your elevator to slow down and be below the floor and then make this value higher, then the elevator will slow down 0.5 studs below the floor and then creep upwards by this speed until it reaches the final stop offset, which I recommend leaving as 0 if you want your elevator to level properly. So we'll restore these values here. Gradual stop threshold is a little bit daunting as well, but again, I'll explain it. But basically what this does is as the elevator is approaching its final stop offset, this value will reduce the acceleration rate, allowing for kind of more of a gradual stop. The dual stage configuration is used for 2-stage leveling. So some elevators will slow down to their final offset, and then they'll reach a certain final speed, and then they will, but since they are not at the floor yet, they will kind of continue to slow down, but at a lower rate. So that's what this is for. So the elevator will reach this speed here at this distance. So the elevator will be 0.35 studs below the floor, and then the speed will be 0.45. Door open config is basically just for kind of like classic leveling, if you will. So this just whether or not you want to enable it, and then the threshold is how many studs the car is from the floor when the door is open. Alrighty, so here we are presented with the color config for the buttons and the lanterns. This one should be pretty quick and easy, straightforward. You guys should be able to pick up on this right away. So first of all, we got buttons, car buttons, and then the floor buttons. So the floor buttons are straightforward. It just means that this resembles all of the car floor buttons, so the buttons that resemble the floor. Door buttons, you've got open, close, and hold. And then you also have an enable option, so if you don't want these buttons to light up, then you can have that option here. We have the alarm button, which has its separate configuration, and again, these are all color and material inputs, so you can just select anywhere inside these parentheses, and then you can click on this little color wheel, and then you can pick whatever color you want. And if you guys don't really know how to use this like color thingy, just kind of drag it around until you get a color that you like. But I also don't prefer eyeballing this. So for example, head into Studio, and if you go and select a light part from one of your buttons here, then what you can do is take any of these light parts, set the material to neon. So instead of using brick color, use color because it has a better way of selecting a color. And from here, you can just kind of color the button light the way you want it. So you can kind of tone the brightness, which is this little knob right here. And then this is where you can change the color. So for example, if you want to make yours light up white, then just drag it all the way down to the bottom. That's the widest you can get. and then just drag the brightness to your liking. I don't recommend just cranking it up all the way, as full-on neon looks a little bit unpleasant, so kind of go somewhere in the middle like this, then click OK, and then hover over here and just click on the color entry and just do Control-C, or you can right-click and copy, and then you can paste that into here. So just select this and paste in your new color. So that's how you change the color of any of the buttons. Now moving on to the call buttons, it's pretty much the same thing. You just look for up and down, and then it's just the same course, so you can just change these to whatever you like. And for the lanterns, also very straightforward. You have interior and exterior, and in each one, you have up and down. And that pretty much wraps it up for the color configuration. Alrighty, so next up, we have the lantern controller, or the lantern controls. So basically, this is where you config when the lanterns should activate on your elevator. So it's a bit similar to Cortex, it's just kind of the same naming scheme. It's kind of like activate on arrival, activate on stop, all that stuff. So let's get started. First of all, we got activate on arrival. So basically, this controls whether this event will be invoked when the car begins to stop at a floor. So again, that just means that when the elevator starts to arrive at a floor, then this will be invoked. Now, you have a setting for both interior and exterior. Again, they are both the same. So for example, if you want to make the exterior lantern light up when the elevator starts to arrive, then you'll have this enable option. So should this lantern activate at all, ring the chime. So should this also signal like the sound that plays with it. And you also have the delay. So when the elevator begins to arrive, let's set it to 1 second. The elevator starts to arrive 1 second later, then this will activate. And basically for all the other events, it's kind of the same thing. I mean, you've got activate on stop, after door open, exterior wake call means that if the elevator is idle and not doing anything, and then you press the call button and that opens the elevator up, this is when this event will be activated. When the same button pressed is a little bit confusing, but basically, when somebody presses the call button and the elevator is already open, or if the floor button inside the elevator has been pressed and it is the same floor as the elevator's floor, then this will activate. So kind of like how ThyssenKrupp elevators behave, if you will. And that pretty much wraps it up for this section. Alrighty, last but not least, we have the sound configuration. This is where all of the sounds for the elevator will be stored. So to start things off, we have the door sounds, and that is basically just for the open and closing sound. You'll notice we have this floors table, and I also put an example entry in here as well, so you guys can go off of this. But essentially, example floor, replace the hashtag, which is in these square brackets here, with your desired floor number. So remember, don't do this. Don't put this in quote marks. Make sure you put it in a number entry like this, because it could confuse the controller and not actually use it. And then inside is just the same thing. We have open sound and closed sound. So pretty straightforward. And then again, these down here are the global door sounds. So if you don't have a floor used for an open closed sound, then these will be used instead. And now we have the traveling sound, which is just the sound that the elevator makes. It's a looped audio. So if you don't want something that like sounds like it's like looping really badly, make sure you have like a well looped audio, so you can't tell that it's looping. It just kind of sounds constant. And then here we have the speed ramping. So when the elevator is going from 0 to top speed, this is the minimum and maximum constraints for both the pitch and volume. So for example, obviously elevator speed is 0. This will be 0. No sound will be heard. And then by the time the elevator reaches the maximum speed, the audio's volume will be at the max volume, which is 0.3. Same with the pitch. We also got the button sounds. So we have car and call button click. They both are configured the same way. You have an ID, volume, and pitch, and you can also make it looped apparently, which I don't think works. Leave it as false if you don't want your button sounds looping infinitely. And you also got the roll-off configuration again. And then the time positioning. This is something that other elevator controllers do not have as far as I'm aware. So with this system, you can still use one audio ID, but you can essentially separate it into two separate audios. So this can be enabled, so if you disable it, then it'll just play the one sound. But if you have it enabled, you can basically take the press and release sound and split it. So this minimum and maximum just means the start position for this press sound, and then the end of the clip. I don't know why I typed start for this. We're gonna change that to end. Same with this one. I don't know why I put start. Basically, minimum and maximum just means start and end. I don't know why I named it minimum maximum, but that's just how we go. Basically, same thing for release, and the reason why this is math.huge, it just signifies the end of the clip, so it just reaches the end of the audio. But again, you can essentially change this to however you want. Now, I'm going to just give you guys a quick little tutorial on how to do this exactly. So one thing you will need is some kind of audio editing software, something as simple as Audacity. So let's go ahead and fire it up. Alright, so we are here on Audacity, and as you can see, I have already inserted an audio of my choice. So once you have done that, then go ahead and select any part of your audio that you would like to use for your press and release sounds. So for me, we have this little audio, so I'm just going to play it real quick for you guys to hear. That is the sound effect that I have. So usually in most cases, for the press sound, we're just going to select the region for this. That's a sound that you will hear when you press down the button. So we're going to go ahead and take that, and you can see down in the little selection menu here, you'll see that it tells us the start of the selection and the end of the selection. So obviously selection is just a flat 0, and then selection end looks like it's going to be 0.258 seconds. So what we're going to do is head back into Studio, and we're just going to type in 0.258. So that is our end of the press sound. And same thing with the release, just go and select the start and then just drag it to the end. I'm just going to take it to the end because it's literally just the button audio. So our start of the selection is going to be marked at 0.279 seconds. So we're going to head in here, release 0.279, and leave max as math.huge if you just want it to go all the way to the end of the clip. But if you want to constrain it to a specific part of the end, so for example, if you want it to stop here, right around here, then take the end selection, which is the bottom row here, and then just put that in your max value. So that's pretty much how you split the audio up. Just use any basic audio editing software. It does not have to be advanced as long as it works for you. And again, for the call button click sound, it is the exact same thing, so we can just go ahead and jump right over to the next one. Here we have the alarm sound. Very straightforward. It's literally just a looped audio. So when you press the alarm in, it's going to play this audio. And then when you release the alarm, you have the option to give it a release sound. So if you have an audio for a mechanical bell, and you kind of want to add that fade sound, like the sound of the bell fading out, then you can use a separate sound for that as well. And moving on to the nudge signal loop, I don't know why I named this alarm. Maybe I just didn't rename it or something. But this is a nudge signal loop, or I guess otherwise known as the nudge buzzer. So it's just a sound. It's a looped audio that plays while the doors are nudging. So just the ID, volume, pitch, all that good stuff. And here we have the chimes. So we have the floor passing chime, so the little beep that plays when the elevator passes a floor. You can disable this if you like. And then you have the interior up and down chimes, as well as the exterior up and down chimes. These are all configured the same, so you don't really have to change any of these. Now, I went ahead and added a little extra thing into one of the sounds here. So we have this function called onAdd, which is actually used. And what this does is you can basically take this function and use the sound. So the sound is passed through for whatever is being added. So for example, the interior up chime. And you can kind of do whatever you want with this in code. So for example, if you want to do local equalizer, you can add an equalizer sound effect, and then you can just code it to do whatever you want. So you can basically insert an equalizer into the sound. So we'll go ahead and give it a parent just for an example. So you can give the sound an equalizer, you can give it whatever you like. This does work because in Modulux V2, the sounds are added from scratch, so they're not already pre-existed. So if you go into Studio without running it, you'll see there are no sounds that coincide in the elevator. All of those are generated when the elevator starts up. So these kinds of functions kind of allow you to modify the sound without needing to do any weird editing stuff beforehand. But other than that, that pretty much wraps up the sound configuration. So why should you switch to Modulux V2? Modulux V2 is open sourced, up-to-date, and efficient. It uses the latest Roblox code and other efficient code approaches to maintain stability, efficiency, and best of all, modularity. Modulux V2's goal is to sell itself as a highly user-friendly, accurate, and customizable controller for everyone to use. So with that being said, if you'd like to see more tutorials and guides like this, feel free to subscribe. Thank you for watching, and I hope you found this rather lengthy guide helpful. Until next time.